Tonight, we're going to place our entire galaxy next to the structure that actually contains it. The Milky Way is a spinning disk of stars, gas, and dust. It is home to everything we've ever seen with the naked eye, every constellation that has guided sailors for millennia, every star system that has ever been named, mapped, or dreamed about. From the inside, the Milky Way feels like the whole of existence. It is the silent backdrop to every night sky anyone has ever looked up at, the source of every single point of light we've learned to recognize as a species. And yet, against the true scale of the universe, our galaxy is a much smaller piece of the picture than anything you can imagine. By the end of tonight, you're going to understand exactly how small our galaxy really is. You will see how it fits inside groups, clusters, superclusters, and finally, the observable universe itself, and why the true size of everything that exists might be a number we can never actually know. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now let's begin. Start with something familiar. Stand outside on a clear night, somewhere dark enough that the glow of civilization fades away, and look up. There is a faint, ghostly band of light cutting across the darkness from horizon to horizon. That band is the Milky Way. But it isn't the whole Milky Way, because you are currently standing inside it. What you are seeing is the combined glow of billions of stars, so distant that their individual fires merge into a single, soft wash of light. You are looking at the disk of our galaxy, seen edge-on from within. To understand our place in this structure, we have to look at the Milky Way as astronomers do. We live in what is classified as a barred spiral galaxy. Imagine a flat, rotating disk of stars and dust wound into sweeping spiral arms that wrap outward from a brilliant center. At the heart of this disk is a dense central bulge, a place where stars are packed together so tightly that if you lived on a planet there, you would never know a true night. Even when your world turned away from its sun, the sky would continue to glow with the light of 1,000 nearby neighbors. Running through that bulge is a long, elongated bar of stars, a structural spine that holds the center of our world together. And at the absolute center of everything, the gravitational anchor of the entire galaxy, sits a supermassive black hole called Sagittarius A. Its mass is roughly 4 million times the mass of our Sun, all compressed into a region of space smaller than the orbit of Mercury. It is the silent engine of the Milky Way, the dark sun around which everything we know revolves. The disk of the Milky Way spans about 100,000 light-years in diameter. Some measurements, reaching further into the dim outer edges, push that number to 120,000. To a human mind, a light-year is already an impossible distance, 10 trillion kilometers. To cross our galaxy at the speed of light would take 1,000 human lifetimes. The disk is also extraordinarily thin relative to its width, only about 1,000 light-years from top to bottom in its densest regions. You are living inside a structure that is roughly 100 times wider than it is thick. It is a cosmic dinner plate scaled up to galactic proportions, made of fire and vacuum. Our Sun sits about 26,000 light-years from the galactic center. This puts us slightly more than halfway out from the core to the visible edge. We are not at the center where the stars are crowded, nor are we at the lonely edge where the galaxy fades into the void. We are in the suburbs. We orbit the galactic center at about 500,000 miles per hour. Yet at that terrifying speed, one complete orbit takes approximately 225 million years. Astronomers call this a galactic year. In the entire history of complex life on Earth, since the first creatures crawled out of the oceans, our Sun has only completed 2 full orbits of the Milky Way. Over its entire 4.5 billion year lifetime, it has only gone around 20 times. The Milky Way contains somewhere between 100 billion and 400 billion stars. The range is wide because counting stars from the inside is a nearly impossible task. We cannot step outside and take a photograph of our home. We are embedded in the disk, surrounded by clouds of gas and dust that block our view in almost every direction. There are entire regions of the galaxy, hidden behind dense pillars of interstellar soot, that we have never seen with optical telescopes. We use infrared light to peer through these clouds, but even then our map is a work in progress. The lower estimate of 100 billion stars is already a number our brains were never built to hold. If you were to count one star per second, without sleeping or pausing, it would take you over 3,000 years just to reach 100 billion. Most of these stars are red dwarfs, small, dim, and patient. They burn for trillions of years, far longer than the current age of the universe. Some of the stars in our galaxy today formed shortly after the Big Bang. They were there before our sun existed, and they will still be burning long after our sun has turned into a white dwarf and faded from memory. The Milky Way is not just enormous in space, it is enormous in time. It is a structure 13 billion years old, a survivor of a cosmic era we are only beginning to understand. But as vast as this sounds, as impossible as it feels to be one sun among 400 billion, we have to confront a much larger reality. Because the Milky Way, for all its majesty, is about to become a microscopic participant in a structure that outscales it by nearly 1 million times. We often confuse our galaxy with the universe, but the observable universe is a different concept entirely. It is not a place, it is a limit. It is the portion of everything that exists from which light has had enough time to reach us since the beginning of time. The universe is 13.8 billion years old. Light travels at a fixed speed. You might expect the radius of the observable universe to be 13.8 billion light years. But because space has been expanding while that light was in transit, the actual radius is 46 billion light years. The observable universe is a sphere 93 billion light years across. Now place the Milky Way next to that number. 100,000 light years versus 93 billion. To get from our galaxy to the edge of what we can see, you would have to multiply the size of the Milky Way by nearly 1 million. There is no everyday analogy that can capture this gap. It is too large for human experience. What matters is the realization that we are living inside a microscopic bubble of light. And as we leave the comfort of our suburbs and zoom out further, we are going to see that our galaxy is not a lonely island. It is part of a family, a group that is heading toward a destination we cannot see, pulled by a force we are only just beginning to name. But as we prepare to cross the threshold of our galaxy, we have to face an unsettling reality. The Milky Way is not just a speck in the void, it is a speck that is currently being hunted. Something massive, hidden behind the very dust of our own stars, is pulling us through the dark at over 1 million miles per hour. We often think of our galaxy as a permanent fortress, but we are about to discover that the backyard of our solar system is not as empty as it seems. In the next section, we are going to leave the light of the spiral arms and enter the absolute darkness of the solar backyard. We will see the invisible skeleton that holds our galaxy together, and we will confront the terrifying force that is dragging our entire neighborhood toward a collision that will erase every constellation you see in the sky tonight. The scale is about to explode, and the only thing more frightening than how small we are is what is waiting for us in the dark. To understand the scale of what is hunting us, we have to start at the very edge of our own backyard. Most people believe that the solar system ends with Pluto, a lonely, frozen rock orbiting in the outer reaches of the sun's light. We draw our maps with Pluto at the finish line, as if that is the point where the familiar world stops and the galaxy begins. But as we zoom out, we realize that Pluto is just a waypoint on a much longer journey. Beyond the planets, stretching for nearly a light year in all directions, is a vast, icy shell called the Oort cloud. It is a graveyard of trillions of comets, remnants of the birth of our sun that drift in the eternal cold. This is the true property line of our home, and it is here that we encounter our first pattern interrupt, a realization that challenges everything we know about space. Even if you were to travel to the very edge of this cloud, you would still be within the sun's gravitational grip. You haven't truly entered the galaxy yet. You are still in the driveway. And as you look back, you realize that the sun, which feels like the center of the universe to us, is just one flickering candle in a forest that is currently being reshaped by an invisible force. But as we leave the Oort cloud behind and step into the true interstellar void, we hit a wall that no telescope can see. We have been taught that the Milky Way is a collection of stars and gas, held together by the gravity of its central black hole. We look at the beautiful spiral arms and assume that is the whole galaxy. But astronomers have discovered a terrifying discrepancy. If you add up the mass of every star, every gas cloud, and even the supermassive black hole at the center, the Milky Way doesn't have enough gravity to stay together. By all the laws of physics we understand, our galaxy should have flown apart billions of years ago. The stars at the edges are moving too fast, screaming through the dark at speeds that should have sent them drifting into the intergalactic void. This is where we encounter the invisible skeleton of our world, the dark matter halo. Imagine our galaxy as a beautiful glowing skin. What we have recently learned is that this skin is stretched over a gargantuan, invisible frame. The Milky Way is embedded inside a sphere of dark matter that is 6 times larger than the visible disk of stars. This dark matter doesn't emit light, it doesn't reflect it, and it doesn't block it. It is a ghost substance that passes through your body every second as you listen to this, and yet it is the only thing keeping our home from disintegrating. We are living inside a structure that is 90% invisible. We have spent our history mapping the 1% of the universe that glows, completely unaware that the other 99% is a dark, heavy ocean that is dictating our fate. As we move past this dark matter halo, the scale of the nothing begins to dominate. On Earth, we think of a vacuum as empty space, a place where nothing happens. But as we zoom out into the backyard between the Milky Way and its nearest neighbors, we find that the void is not empty, it is alive. This is the intergalactic medium, a thin soup of hydrogen atoms so spread out that there is only one atom for every cubic meter of space. It is the emptiest place in existence. And yet this nothingness is the stage for a violent thermal battle. The gas between galaxies is heated to millions of degrees by the radiation of active black holes and exploding stars. You are drifting through a region that is simultaneously the coldest and the hottest place you can imagine. But here is the wait, what moment. Even in this absolute emptiness, there is a pressure. Space is not just a container, it is a fabric, and that fabric is currently expanding. Every second, the distance between the Milky Way and the distant clusters of the universe is growing. It's as if you're standing in the center of a room where the walls are slowly moving away from you. You aren't walking, yet you are getting further from your destination. We are trapped on an island of gravity in a sea of expanding space. But as we look across this sea, we see something that shouldn't be happening. We see our neighbor, the Andromeda galaxy, and it isn't moving away. It is coming straight for us. This is where the hunted loop we opened in the first section begins to take a physical shape. Usually, the expansion of the universe pushes galaxies apart, but the Milky Way and Andromeda are so massive, and their dark matter halos are so large, that they have overcome the expansion of the universe. They are locked in a gravitational death grip. We are currently falling toward each other at 250,000 miles per hour. In about 4 billion years, the night sky will be dominated by the glowing core of Andromeda as it begins to tear the Milky Way apart. But Andromeda isn't the predator we should be worried about. As we zoom out even further, leaving our local family of 80 dwarf galaxies, we realize that our entire group, everything within 10 million light-years, is part of a much larger flow. We are participants in a gravitational choreography that spans 500 million light-years. We are moving toward a region of space hidden behind the gas and dust of our own galaxy. We call it the Great Attractor. It is a concentration of mass so immense that it is dragging tens of thousands of galaxies, including our own, toward a single point in the dark. We are not just drifting, we are being pulled into a gravitational sink. We are like a leaf in a river, moving toward a waterfall we cannot see. To understand where this river is taking us, we have to zoom out one more time, to a scale that makes the Milky Way look like a single drop of water. We are about to enter the Laniakea supercluster, the immeasurable heaven. Here, the individual galaxies disappear, and what remains is a structure that looks hauntingly biological. It looks like the neural network of a brain or the veins in a leaf. These are the filaments of the cosmic web, the largest structures in the known universe. Each thread in this web is made of thousands of galaxies, and each galaxy is made of hundreds of billions of stars. But as we reach this height, we realize the most unsettling truth of all. The more we see, the more we realize we are missing. Laniakea is 5,000 times the diameter of our galaxy. It spans 500 million light-years, but even this massive structure is just one tiny knot in a web that stretches for 93 billion light-years. And here is the cliffhanger loop for the next section. We have spent centuries trying to map this web, believing that if we just build a big enough telescope, we can see the whole thing. But we are about to discover that there is a wall of light that we can never cross. In the next section, we are going to explore the observable limit. We will discover why the universe is hiding 90% of its territory from us, and why the most distant galaxies we can see are actually moving away from us faster than the speed of light. We have seen how big the universe is, but now we must face the terrifying possibility that the part we can see is just a tiny, fading bubble in an infinite abyss that is actively trying to erase our existence. The ladder of scale has reached a point where the numbers stop making sense, and the silence begins to scream. To understand the staggering size of the universe, we must first confront the monster we call home. We've spent our history looking at the Milky Way as a serene, silver river in the sky, a beautiful backdrop for our myths and our dreams. But when you look past the light, you realize that our galaxy is not a peaceful garden. It is a violent, churning machine of fire and shadow, governed by a heart of absolute darkness. We stand at the edge of the observable limit, but to see that far, we must first look back at the monster we live inside. If you want to understand how a structure 100,000 light-years wide can still be considered a microscopic speck, you have to see what that speck is actually made of. You have to realize that our galaxy is not just a collection of stars. It is a layered fortress, a city of billions, all held in the grip of a central engine that challenges the very laws of physics. Start at the absolute center. If you could travel 26,000 light-years inward toward the brightest part of the night sky, you would find the galactic bulge, a region where the vacuum of space is replaced by a dense, glowing fog of ancient stars. Here, the rules of the night are rewritten. On Earth, our nearest neighbor is 4 light-years away. In the core of the Milky Way, stars are packed thousands of times tighter. If you lived on a planet there, your sky would be filled with dozens of suns as bright as the full moon. You would never know a true dark night. But as you push deeper into this brilliance, the light suddenly vanishes. At the very heart of our world sits Sagittarius, a asterisk, a supermassive black hole with the mass of 4 million suns. This is the gravitational anchor of everything you have ever known. Imagine 4 million versions of our sun crushed into a single point in space. It is a region of such intense gravity that even light cannot escape its pull. This is the monster at the center of our home. It is a silent, invisible drain that is constantly warping the spacetime around it, forcing entire clusters of stars to orbit at millions of miles per hour in a chaotic, high-speed dance. This black hole is the reason the Milky Way exists, and yet it is a void that could swallow our entire solar system without a sound. It is a humbling realization. The structure we call home is built around a hole in the universe. As you move away from the core, the galaxy flattens out into what we call the thin disk. This is the part you see in photographs, the sweeping spiral arms made of hot blue stars and glowing gas clouds. This disk is where we live. It is a region of intense activity, where new stars are being born in the Orion Nebula and the Eagle Nebula, collapsing from cold clouds of hydrogen into nuclear furnaces. But our home is even more layered than it appears. Wrapped around this thin disk is the thick disk, a much older, much ghostlier region of space. This thick disk is populated by population 2 stars, ancient, red-lit suns that were born when the galaxy was in its infancy, over 10 billion years ago. These stars carry the chemical signatures of a younger, simpler universe. They move in erratic, inclined orbits, like a chaotic swarm of bees around a hive. This is where we hit our next pattern interrupt. We often think of the galaxy as a single, uniform structure, but it is actually a city built on top of its own ruins. The thick disk is the remnant of an earlier era, a skeletal version of the Milky Way that existed long before our sun was even a spark. We are newcomers living in a modern suburb, surrounded by the ancient, crumbling infrastructure of a cosmic ancestor. But as we zoom out further, past the spiral arms and past the thick disk, we enter the galactic halo, a massive spherical graveyard that surrounds our entire world. This is perhaps the most mysterious part of our home. The halo is filled with globular clusters, tightly packed spheres of up to 1 million stars, all orbiting the galaxy like miniature moons. These clusters are the oldest objects in the Milky Way. They are over 12 billion years old, meaning they were formed shortly after the Big Bang itself. They have survived for nearly the entire history of time, watching from the darkness as our galaxy merged, grew, and evolved. But here is the what moment that changes how you see the Milky Way. Many of the stars in this halo don't actually belong to us. Astronomers have discovered stellar streams, long arcing trails of stars that have different chemical compositions than our own. These are the remains of smaller galaxies that the Milky Way has digested over the last 10 billion years. Our galaxy is a predator. It grows by tearing apart its neighbors and absorbing their stars into its own halo. Right now, the Sagittarius dwarf galaxy is being shredded by our gravity, its stars being woven into the fabric of our world as we speak. The Milky Way isn't just a spinning disk. It is a vampire galaxy that has been consuming its family for eons. And yet, even this monstrous structure, with its 400 billion stars, its supermassive black hole, and its graveyard of consumed galaxies, is still missing its most important part. As we discussed, 90% of the Milky Way's mass is invisible. We call it dark matter. If you could see the dark matter halo, the Milky Way would no longer look like a flat disk. It would look like a gargantuan glowing sphere, spanning 600,000 light years. This invisible shell is the only reason we haven't flown apart. It is the skeletal frame that holds the monster together. But now take this entire monster, the black hole, the spiral arms, the ancient halo, and the 600,000 light-year dark matter shell, and look at the scale of the universe once more. We have just described a structure of unimaginable power and size, but in the next section, we are going to see this monster shrink. We are going to enter the local group, where we will discover that our digesting galaxy is about to become the meal. We will see how the Milky Way fits into a neighborhood of 80 galaxies, and why our massive black hole is nothing compared to the monsters waiting for us in the Virgo cluster. We are moving from a single monster to a pack of predators. We are about to realize that the backyard of our galaxy is part of a flow that is being dragged toward the great attractor. What happens when our whole galaxy is just a leaf caught in a gravitational storm? And why is the space between us and Andromeda the most high-stakes territory in the universe? The ladder of scale is about to take another jump, and the monster you just met is about to look like a toy. To understand the true scale of the universe, we have to look past the boundaries of our own home and realize that the Milky Way is not a lonely traveler. In our daily lives, we think of ourselves as isolated individuals, but we are part of families, cities, and nations. Our galaxy follows the same rule. It is a member of a cosmic neighborhood, a collection of roughly 80 galaxies that astronomers call the local group. But as we step out into this intergalactic backyard, we find that the serenity of the stars is replaced by a violent, high-speed choreography. We are about to discover that our galaxy is locked in a gravitational death grip with its neighbor, and that the space between us is not a peaceful void, but a staging ground for a collision that will dismantle everything we know. In this section, we are going to climb the next rung of the ladder and see the Milky Way shrink from a monster into a mere member of a pack that is currently falling toward a much darker fate. Start with the most distant object the human eye can perceive without help. On a clear, dark night, if you look toward the constellation Andromeda, you will see a tiny, fuzzy smudge of light. It looks like a thumbprint on the lens of the universe, a ghost of a star that doesn't quite fit the pattern. This is the Andromeda Galaxy, also known as M31. It is the largest member of our local group, a sister spiral that contains over 1 trillion stars, more than double the population of the Milky Way. When the light you see from Andromeda enters your eye tonight, it has been traveling through the absolute zero of the void for 2.5 million years. You are looking at Andromeda as it was when our ancestors, Australopithecus, were first carving stone tools in the African savanna. To understand the distance, imagine the massive 100,000 light-year disk of the Milky Way as a single silver coin. To reach Andromeda, you would have to lay 25 of those coins in a straight line. That is our nearby neighborhood. Andromeda is a mirror image of our own home, but on a more terrifying scale. It has its own supermassive black hole at its center, one that is significantly more active and massive than our own Sagittarius A. It has its own sprawling spiral arms, its own nurseries of blue giant stars, and its own dark matter halo that stretches for millions of light years. For billions of years, we have lived as separate island universes, but what moment of our neighborhood is this? We are no longer drifting apart. While the rest of the universe expands, the mutual gravity of our two galaxies has overcome the expansion of space itself. We are currently hurtling toward each other at 250,000 miles per hour. We are on a collision course with our twin. This is where the hunted loop from Section 1 becomes a physical reality. We are falling. In about 4.5 billion years, just as our sun begins to exhaust its hydrogen fuel and swell into a red giant, the Milky Way and Andromeda will finally meet. But this will not be a crash in the way we understand it on Earth. Galaxies are mostly empty space. If two galaxies were to collide, the chances of two individual stars actually hitting each other are nearly zero. It would be like two swarms of bees passing through one another. However, while the stars might miss each other, their gravity will not. This encounter will be a gravitational demolition derby. The beautiful, orderly spiral arms of both galaxies will be torn apart by tidal forces, stretched into long, glowing ribbons of gas and stars that will span millions of light years across the sky. These are called tidal tails. The night sky for any creature living in that era will transform from a calm band of silver into a chaotic, psychedelic display of cosmic fire. Over hundreds of millions of years, the two galaxies will pass through each other, swing back around, and eventually merge into one. The result will be a new massive elliptical galaxy that astronomers have already named Milkomeda or Milkdromeda. The constellations you know today, the Hunter, the Lion, the Bear, will be erased forever. Their stars will be scattered into new, irregular orbits, and the whole of existence we mapped in the first section will become nothing more than the raw material for a future world. But the local group is more than just two giants. It is a strict hierarchy of power. Orbiting the Milky Way and Andromeda are dozens of dwarf galaxies, small, irregular collections of a few million to a few billion stars. The most famous are the Large and Small Magellanic Clouds, visible from the southern hemisphere as fuzzy patches of light. To us, they look like peaceful companions, loyal moons of our galaxy, but the truth is much darker. The Milky Way is a gravitational bully. We are currently stripping the gas and stars away from these dwarf galaxies, creating a massive trail of debris called the Magellanic Stream that wraps halfway around our sky. We grow by consuming our neighbors. This is a process called galactic cannibalism. Every few 100 million years, one of these dwarf galaxies falls too close to our gravitational well and is digested. Their stars are torn out of their original homes and woven into the fabric of the Milky Way's halo. Right now, a small structure called the Sagittarius Dwarf Spheroidal Galaxy is passing through our disk, being shredded as we speak. This is how the local group functions. The large galaxies get larger by eating the small ones, all while the two biggest members prepare to eat each other. We think of space as a vacuum where nothing happens, but on the scale of 10 million light-years, it is a scene of constant, slow-motion predation. We are part of a family that survives by consuming its own. As we move past these individual galaxies, we must look at the space between them. We often imagine the gap between the Milky Way and Andromeda as a perfect empty void, but it isn't. This is the intergalactic medium IgM. It is a thin, ghostly fog of ionized hydrogen gas. While it is incredibly sparse, with only a few atoms per cubic meter, it is not cold. This gas is heated to temperatures of hundreds of thousands or even millions of degrees. It is a warm, hot plasma that glows in X-rays, invisible to our eyes but felt by the galaxies moving through it. When a galaxy like the Milky Way moves through this intergalactic fog at high speeds, it experiences something called ram pressure stripping. It is the cosmic equivalent of a person running into a strong wind and having their hat blown off. For a galaxy, the hat is its cold gas, the raw material it needs to make new stars. If a galaxy falls too fast into a crowded region, the intergalactic wind can blow its gas away, leaving it red and dead, incapable of ever giving birth to another star. Our Milky Way is currently protected because we live in a low-density suburb of the local group. But as we zoom out further, we see that our entire neighborhood is being dragged toward a place where the intergalactic winds are much more violent. And yet, even this entire group, Andromeda, the Milky Way, the Triangulum Galaxy, and all 80 dwarf companions, is still just a microscopic cluster. As we zoom out further, leaving our 10 million light-year neighborhood, we realize that the local group is not stationary. We are being dragged. We are currently on the outskirts of a much more violent region of space, the Virgo cluster. Imagine our local group as a single house on a quiet street. The Virgo cluster is a bustling city of over 1,000 galaxies, dominated by elliptical monsters like Messier 87. M87 is so large it makes the Milky Way look like a dwarf, and it contains a black hole that is 1,000 times more massive than our own. The entire local group is falling toward this cluster at over 100 miles per second. We are being pulled by the gravity of thousands of galaxies, all working together to harvest us. But Virgo itself is just one small part of an even larger structure. We are about to enter the scale of Laniakea, where our entire neighborhood shrinks until it is invisible. We are moving from a single house to a city, and soon, we will see that City is just one drop in an ocean that spans 500 million light-years. In the next section, we are going to explore the Laniakea supercluster and the Great Attractor. We will discover why our entire region of the universe is flowing like a river toward a hidden point in the dark, and why the veins of the universe look hauntingly like the connections in a human brain. The ladder of scale is about to take its most terrifying jump yet. We have seen our galaxy become a member of a group. Now, we will see that group become a single atom in a cosmic body. Are we moving toward a destination, or are we just part of a flow that has no end? To understand where our galaxy is being taken, we must first abandon the idea of space as a static container. For centuries, we looked at the sky and saw stars as isolated points of light, suspended in a vacuum like dust motes in a beam of sunlight. We thought of our position as a stable coordinate, a home that stayed where we left it. But in the last decade, we have discovered that the universe is not a collection of objects, but a series of currents. We are not just drifting, we are part of a massive, intergalactic flow. In this section, we are going to climb the fifth rung of the ladder and enter the Laniakea supercluster. We are going to discover that our entire local group, the 80 galaxies we just explored, is nothing more than a single drop of water in a river that spans 500 million light-years. We are about to see our galaxy shrink until it is invisible, as we confront the immeasurable heaven and the hidden predator that is dragging us into the dark. In 2014, a team of astronomers led by Brent Tully at the University of Hawaii announced a discovery that fundamentally changed the map of the universe. They had spent years painstakingly measuring the velocities of thousands of galaxies, but they weren't looking at the speed caused by the expansion of the universe. They were looking at something much more subtle, peculiar velocity. This is the extra motion caused by the gravitational pull of nearby mass. By mapping these flows, they realized that galaxies are not scattered randomly. They are organized into basins, much like the way water flows on Earth. Imagine you are standing on a mountain range. Every drop of rain that falls on one side of the ridge flows into one river, while every drop on the other side flows into a different ocean. These are watersheds. Tully and his team discovered a cosmic watershed so vast it defies human logic. They called it Laniakea, a Hawaiian word meaning immeasurable heaven. It is a structure that spans 500 million light-years and contains over 100,000 galaxies. Our Milky Way sits on the very outer edge of this structure, near a boundary called the local void. We are like a house built on the edge of a massive, invisible continent, looking out into an empty ocean. When we look at the first three-dimensional maps of Laniakea, we see something haunting. It doesn't look like a collection of spheres or disks, it looks biological. It resembles the neural network of a human brain, the delicate veins in a leaf, or the structure of a sea sponge. Laniakea is made of long, thin filaments of galaxies that all converge toward a central point. This is where we hit our first pattern interrupt. The large-scale structure of the universe mirrors the structure of life. We often think of gravity as a simple force that pulls two rocks together. But on the scale of 500 million light-years, gravity acts as an architect, weaving the matter of the universe into a complex web. Every galaxy in Laniakea is moving along these veins, flowing like blood toward a gravitational heart. You are not a stationary observer on a planet. You're a participant in a choreography that has been unfolding for 13 billion years. We are being harvested by the architecture of the cosmos, moving along tracks that were laid down in the first seconds after the Big Bang. But as we look at the flow of Laniakea, we encounter a mystery that has baffled astronomers for decades. If Laniakea is a river, then where is it flowing? The answer is a region of space called the Great Attractor. It sits about 250 million light-years away, in the direction of the constellation Centaurus. It is a concentration of mass so immense that it is dragging tens of thousands of galaxies, including our own Milky Way, toward it at staggering speeds. But here is the wait, what moment. For a long time we couldn't even see what the Great Attractor was. It lies in a part of the sky called the zone of avoidance. This is not because the universe is hiding it, but because the very dust and gas of our own Milky Way disk block our view. We are trying to see our destiny through a fog of our own making. Only recently, using infrared and radio telescopes that can peer through the dust, have we realized that the Great Attractor is not a single object. It is a massive complex of galaxy clusters, a gravitational sink that is swallowing the light and matter of 100,000 galaxies. We are falling into a hole in the universe that we can barely see, and there is no way to turn back. To truly grasp the size of Laniakea, we must return to our silver coin analogy. If the Milky Way is a single silver coin, then the local group we explored in Section 4 is a small pile of coins on a table. But Laniakea is a structure 5,000 times larger than our galaxy. On this scale, the Milky Way is not even a pixel. It is a subatomic detail. Laniakea contains more stars than there are grains of sand on every beach on Earth. It is a structure so large that light, the fastest thing in existence, takes 500 million years just to cross from one side to the other. When you look at the stars tonight, remember that you are not just looking at a sky. You are looking at the interior of a heaven so vast that our entire human history has occurred in the time it takes a galaxy to move just a fraction of a percent across its width. We are dwellers of a microscopic suburb on the edge of an infinite city. But as we reach this peak of scale, we realize the most unsettling truth of all. Laniakea is not the end. It is not the whole. It is just one knot in a fabric that is even more terrifying. As we move past the Great Attractor, we see that Laniakea itself is moving. It is being pulled toward an even larger concentration of mass called the Shapley concentration. We are part of a nested series of flows, a river flowing into an ocean, which flows into a larger ocean still. We are about to enter the scale of the cosmic web, where individual superclusters like Laniakea become mere threads in a network that fills the entire observable universe. In the next section, we are going to explore the cosmic web and the great voids. We will discover why the universe is 90% nothing, and why the largest structures ever discovered are not made of matter, but of emptiness. We will see the Hercules Corona Borealis Great Wall, a structure so massive it shouldn't even exist according to our current laws of physics. The ladder of scale is about to break, and as we look out at the filaments of the universe, we will realize that we are looking at the very nervous system of the cosmos. But if this is the nervous system, then where is the brain? And what happens when the threads of this web begin to snap? To understand the architecture of the universe, we have to let go of the idea of galaxies as individual objects. Up until now, we have looked at the Milky Way as a monster, the local group as a neighborhood, and Laniakea as a river. But as we zoom out to the furthest possible limits of our technology, we realize that the universe is not a collection of things. It is a single, interconnected fabric. This is the cosmic web, the largest and most complex structure in existence. It is the skeleton of the universe, a gargantuan network of filaments and voids that stretches for billions of light years. In this section, we are going to climb the sixth rung of the ladder and discover that Laniakea, our immeasurable heaven, is nothing more than a single, fragile thread in a web that fills the entire observable universe. We are about to see that the universe is not chaotic, it is organized, and its organization mirrors the very nervous system of a living being. To understand why the universe looks like a web, we have to travel back 13.8 billion years, to the first tiny fraction of a second after the Big Bang. In that moment, the universe was perfectly smooth, but not perfectly uniform. There were tiny, microscopic fluctuations in density, ripples in the fabric of space that were caused by quantum mechanics. As the universe underwent a period of rapid expansion called inflation, these tiny subatomic ripples were stretched to cosmic scales. This is the what moment of cosmic history. The largest structures we see today are actually the shadows of the smallest things that ever existed. Over billions of years, gravity took these tiny dense spots and acted as an amplifier. Dense regions began to pull in more matter, while less dense regions began to empty out. This created a snowball effect that lasted for eons. Matter began to flow along invisible tracks, gathering into long, thin filaments and massive clusters. What we see today as the cosmic web is the final result of that ancient tug of war. We are living inside a structure that was predetermined by the laws of quantum physics before the first star was ever born. When we look at a map of the cosmic web, we see long, glowing threads of light connecting dense nodes. Each thread or filament is made of thousands of galaxies, millions of light years long. But as we zoom out further, we encounter structures so massive they challenge our very understanding of physics. We discover the Great Walls. The first was the CFA Great Wall, found in 1989, spanning 500 million light-years. Then came the Sloan Great Wall, 1 billion light-years across. But the pattern interrupt happens when we find the Hercules Corona Borealis Great Wall. This structure is 10 billion light-years long. To put that in perspective, it is 100,000 times the diameter of our galaxy. It is so large that according to the cosmological principle, the idea that the universe should look the same in every direction, it shouldn't even exist. There hasn't been enough time since the Big Bang for gravity to move matter across such a vast distance to build something this big. The Hercules Corona Borealis Great Wall is a glitch in our understanding of the universe. It is a structure that is too big for its own age, a haunting reminder that there are laws of scale we have yet to discover. But the web is not just made of light, it is defined by its shadows. Between the glowing filaments of galaxies lie the great voids. These are massive, spherical bubbles of absolute nothingness. If the filaments are the bones of the universe, the voids are the empty spaces in between. Some of these voids, like the Boötes void, are 330 million light-years in diameter. Imagine being on a planet in the center of the Boötes void. If you looked up at the night sky, you would see nothing but blackness. No stars, no galaxies, no nebulae. You would believe that you were the only thing in existence. To see another galaxy, you would have to travel for millions of years at the speed of light. These voids are the emptiest places in the universe, representing 90% of its total volume. We live in a universe that is mostly made of nothing, and the galaxies we call home are just the thin, fragile foam on the surface of a black ocean. This is the existential dread of scale. We are huddling together on the thin threads of a web, surrounded by a vacuum so vast it could swallow 1 trillion Milky Ways without a ripple. To truly grasp the size of the cosmic web, we must look at its biological resemblance once more. If you were to take a slice of the human brain, the neural network that processes your thoughts, and place it next to a simulation of the cosmic web, you would find that they are nearly identical. This is not a coincidence of art, it is a coincidence of physics. Both systems are governed by the laws of efficient self-organization. Both are trying to connect points of density through the shortest possible paths. But here is the final scalar shock of the web. We have spent this entire section mapping the matter we can see, but as we discussed in section 3, the matter we see is only 5% of the truth. The filaments of the cosmic web are actually made of dark matter. The galaxies, the billions of suns and trillions of planets, are just the Christmas lights hanging on an invisible tree. We are living inside a ghost structure, a dark skeleton that spans the entire observable universe. Our entire existence is a decorative detail on a dark matter machine that is billions of times larger than we can perceive. As we reach the peak of the cosmic web, we realize that we have mapped everything that light can reach. We have seen the filaments that stretch for 10 billion light years. We have seen the voids that define our isolation. But now we must face the most terrifying wall of all. Up until now, we have assumed that if we just build a bigger telescope, we can see forever. But we are about to discover that the universe has a horizon, a point beyond which the light can never reach us. In the next section, we are going to explore the observable limit. We will discover why the universe is 93 billion light-years wide, even though it is only 13 billion years old. We will see why the most distant galaxies we can see are already gone, and why the speed of light wall means that we are living in a fading bubble of history. The ladder of scale is about to hit the ceiling of reality, and as we look out at the edge of the observable universe, we will realize that the everything we have just mapped might be the only thing we are ever allowed to know. Are we trapped inside a horizon of our own making? And what lies in the abyss beyond the light? We have reached the ceiling of our perception. We have climbed the ladder from the suburbs of the sun to the gargantuan filaments of the cosmic web, witnessing structures so massive they defy the very laws of time. But as we stand at this height, looking out across a fabric woven of trillions of galaxies, we encounter a wall that no amount of technology can ever penetrate. This is the observable limit, the ultimate boundary of the human eye. Up until now, we have assumed that if we just build a bigger mirror or a more sensitive sensor, we can see forever. We imagine the universe as a dark room where we just need a stronger flashlight, but the reality is far more haunting. The universe is not a room, it is a fading bubble of history. We are trapped inside a horizon of light, and beyond that horizon lies an abyss that is actively receding from us, taking the secrets of the everything with it. In this section, we are going to explore the 93 billion light-year diameter of our sight and discover why the most distant things we see are already ghosts of a reality that no longer exists. To understand the observable limit, we must first confront the most absolute rule of the universe, the speed of light. We have been taught that light is the fastest thing in existence, traveling at 300,000 kilometers per second. It is fast enough to circle the Earth 7 times in a single heartbeat. But as we have seen throughout this journey on the scale of the cosmos, the speed of light is a crawl. It is an agonizingly slow messenger. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. And when you look at the most distant galaxies in the Hubble Deep Field, you are looking at light that has been traveling for over 13 billion years. This is the time machine trap of astronomy. We never see the universe as it is right now, we only see it as it was. The farther we look into space, the deeper we look into the past. This creates a natural boundary. If the universe is 13.8 billion years old, then the furthest light that could have possibly reached us is the light that started its journey at the very beginning of time. This is our horizon. Anything beyond that distance is invisible to us, not because it isn't there, but because its light hasn't had enough time to reach our eyes yet. We are living in a sphere of light, centered on the Earth, and the edges of this sphere define the everything we are allowed to know. But here is where we encounter the great what moment of modern cosmology. If the universe is 13.8 billion years old, you would logically assume that our observable bubble is 13.8 billion light-years in radius. But when astronomers measure the distance to the most ancient light we can see, they don't find a 13 billion light-year gap. They find a distance of 46 billion light-years. This means the observable universe is 93 billion light-years wide. How is this possible? How can light travel 46 billion light-years in only 13 billion years? The answer is the most mind-bending fact in physics. Space has been expanding while the light was traveling. Imagine you are standing on a massive rubber floor. You start running toward a friend who is 10 meters away. But as you run, the rubber floor beneath your feet is being stretched. Even though you are moving forward, the distance you have to cover is growing. By the time you reach your friend, you have physically run for only 10 meters, but the space between your starting point and your friend is now 30 meters wide. This is exactly what has happened to the light from the first galaxies. When that light was emitted, those galaxies were much closer to us. But during the 13 billion years that light spent traveling through the void, the space between us and those galaxies was stretching. The ground was moving beneath the light. Today, the galaxies that sent that ancient light are now 46 billion light years away. We are looking at a universe that has outrun its own light. This realization leads to a terrifying conclusion. We are surrounded by ghosts. When we look at a galaxy at the edge of the observable universe, we see a tiny blue-white smudge of a baby galaxy, born just after the Big Bang. But that is not what that galaxy looks like now. In the now of the universe, that galaxy is likely a massive, red, dying elliptical structure, where it may have merged with dozens of others to become something unrecognizable. Or worse, it may already be dead. We are looking at a map of the past, not a map of the present. We are like historians trying to understand a city by looking at a photograph taken 1,000 years ago, unaware that the buildings have already crumbled and the streets have been rewrit. The deeper we go into the scale of the universe, the more we realize that our perspective is a lie. The 93 billion light-year bubble we inhabit is a cemetery of light, filled with images of things that are no longer there. We are chroniclers of the deceased, mapping a cosmic history that the universe has already moved past. But the observable limit is not a static wall, it is a leaking bucket. We live in a universe dominated by dark energy, a mysterious force that is causing the expansion of space to accelerate. This means that every second, the distant galaxies are being carried away from us faster and faster. Eventually, they will reach a speed where they are moving away from us faster than the speed of light. Here is the pattern interrupt that creates the ultimate existential dread. There are galaxies we can see tonight that we will never, ever be able to visit, even if we could travel at the speed of light. The light they are emitting right now will never reach us. The space between us is growing too fast for the light to ever bridge the gap. We are witnessing the cosmic horizon closing in. As time goes on, more and more galaxies will cross this threshold, disappearing from our sight forever. 100 billion years from now, if any astronomers are left on the Milky Way, they will look up and see nothing. The expansion of space will have carried every other galaxy beyond the observable limit. They will believe their galaxy is the only thing in the entire universe. We are fortunate enough to live in a brief window of time when the universe is still visible. We are catching the last glimpses of a structure that is actively trying to erase itself from our memory. To truly grasp our place in this scale, we must return to our final comparison. If the Milky Way is a grain of sand and the observable universe is a football stadium, we have just reached the walls of that stadium. We have mapped the seats, the field, and the rafters. But as we look at those walls, we realize they are not the end of the world. They are just the end of our sight. What lies beyond the 93 billion light years? What exists in the unobservable abyss? Is the universe infinite? Or is it just another knot in a fabric we can't even imagine? In the next section, we are going to explore the unobservable abyss and the multiverse paradox. We will discover why the everything we just spent an hour mapping might be less than a fraction of a percent of the true universe. We will see the speed of light wall from the other side, and we will confront the possibility that we are living in just one bubble in an infinite ocean of big bangs. The ladder of scale has reached the edge of physics, and as we step off, we will realize that the bigness of the universe is a number that may not even have an end. Are we ready to face the infinity that light is hiding from us? We have reached the ultimate boundary of causality. Throughout this journey, we have climbed a ladder of staggering proportions. witnessing the Milky Way shrink from a monstrous city of stars into a single, lonely thread in the cosmic web. We have looked out across 93 billion light-years of space, mapping the everything that light has allowed us to see. But as we stand at the edge of this observable bubble, we encounter a wall that is more absolute than any mountain and more impenetrable than any fortress. This is the speed of light wall. It is the speed limit of the universe, and it is the reason we are fundamentally, permanently isolated from the rest of infinity. Up until now, we have treated the speed of light as a tool, a cosmic yardstick that lets us measure the past. But in this section, we are going to see the speed of light for what it truly is, a cage. We are going to discover why the universe is actively hiding its true size from us, and why the faster we try to look, the more the cosmos seems to pull away, leaving us in a fading pocket of history that is shrinking with every passing second. To understand why we are trapped, we must first confront a fundamental misunderstanding of what light actually is. On Earth, we think of light as instant. When you flip a switch, the room is filled with illumination. When you look at a distant mountain, you assume you are seeing it as it is right now. But as we move into the scale of the universe, we realize that light is not a messenger of the present. It is a ghost of the past. The speed of light, 299,792,458 meters per second, is the absolute ceiling of the universe. Nothing that has mass can ever reach it, and no information can ever travel faster than it. This is not because our engines are too weak. It is because the fabric of space-time itself refuses to allow it. Imagine the universe is a massive, infinite library, but the books are being delivered to you by a courier who can only walk at a specific, unchanging pace. If a book was written 1,000 miles away, it will take days to reach you. If it was written on the other side of the world, it might take weeks. By the time you read the news, the events in the book are already over. This is our reality. When we look at the Andromeda galaxy, we are reading a book that was sent 2.5 million years ago. When we look at the edge of the observable limit, we are reading a book that was sent 13 billion years ago. The speed of light wall ensures that we can never, ever know what is happening in the universe right now. We are perpetually locked in the past, looking at a sky that is nothing more than a collection of ancient, out-of-date signals. But why can't we just go faster? We've always believed that technology will eventually break every barrier. We broke the sound barrier, we broke the gravity of Earth. Surely, we will one day break the light barrier. But here is the wait. What moment of physics? The speed of light is not just about how fast a photon travels. It is the speed of causality itself. It is the speed at which cause leads to effect. If you were to somehow travel faster than light, you wouldn't just be moving fast. You would be moving out of the logical structure of the universe. You would arrive at your destination before you even left. You would see the effect before the cause. The universe prevents this through the mass-energy penalty. Einstein's famous equation, E equals mc2, tells us that mass and energy are two sides of the same coin. As an object approaches the speed of light, its mass begins to increase toward infinity. To push that infinite mass even a fraction of a millimeter faster would require an infinite amount of energy. The entire energy of every star, every galaxy, and every black hole in the observable universe would not be enough to push a single grain of sand to the speed of light. The wall is not a physical barrier we can crash through. It is a mathematical law that governs the very existence of matter. We are made of atoms, and atoms are bound by the speed of light. To reach the stars, we are trying to run a race in a world where the floor becomes heavier the faster we move. Now take this speed limit and place it inside an expanding universe. This is where the cage becomes truly terrifying. As we discussed in Section 7, space is stretching. The distant galaxies are not moving away from us in the traditional sense. The space between us and them is growing. And here is the mind-blown reality. There is no limit to how fast space can expand. General relativity allows the fabric of the universe to stretch at any speed, even speeds that dwarf the speed of light. Imagine you are trying to reach a galaxy that is currently 10 billion light-years away. You build a ship that can travel at 99% of the speed of light. You fire your engines and begin your journey, but while you are traveling, the space in front of you is stretching. The galaxy you are aiming for is being carried away by the expansion of the universe at a rate that is faster than you are moving. You are like an ant trying to walk across a treadmill that is being pulled faster than the ant can run. No matter how long you walk, no matter how much energy you expend, the distance to your destination will never shrink. In fact, it will grow. This is the eternal separation. Because of the speed of light wall, 97% of the galaxies in our observable bubble are already unreachable. Even if we left today at the fastest speed allowed by the laws of physics, we would never arrive. They are gone. The universe is a house where the rooms are moving away from each other so fast that we can only ever stay in the hallway. But the wall is doing more than just keeping us from traveling. It is actively erasing our map. We live in the era of dark energy, a mysterious force that acts as a cosmic anti-gravity. For the first few billion years after the Big Bang, the expansion of the universe was slow enough that gravity could hold things together. But about 5 billion years ago, dark energy took over. It began to push the expansion into an accelerated phase. Every second, the treadmill is speeding up. Think about what this means for the light from distant stars. A photon leaves a distant galaxy, heading toward Earth. It is traveling at the maximum speed possible. But as it crosses the void, the space behind it is stretching, and the space in front of it is stretching even faster. Eventually, the expansion of space becomes so violent that the light can no longer bridge the gap. It is like a bridge that is being built at one end while the other end is being moved miles away every second. The light will never reach us. It will drift in the void forever, a signal that has lost its receiver. We are witnessing the closing of the cosmic window. Every day, galaxies that were once visible to our telescopes are crossing a threshold called the cosmic event horizon. Once they cross that line, their light can never reach us again. They vanish from our universe, not because they died, but because the space between us became an infinite abyss. This leads us to the final, most haunting realization of the speed of light wall. We often talk about the universe as an infinite frontier, a place of endless possibility. But the physics of light and expansion tell a different story. They tell us that we are living on a sinking island. Right now, we can see 2 trillion galaxies. We can map the cosmic web. We can see the fire of the Big Bang, but this is a temporary privilege. 100 billion years from now, the expansion of space will have carried every single galaxy, except for our immediate neighbors in the local group, beyond our horizon. The wall will have moved so close to us that the sky will be empty. Future astronomers will look through their most powerful telescopes and see nothing but absolute blackness. They will have no way to know that the Milky Way was once part of a supercluster. They will have no way to know that there were once trillions of other suns. The speed of light wall is a cosmic sensor, methodically deleting the history of the universe until only our tiny, lonely neighborhood remains. We are catching the last, fading glimpses of a reality that is being systematically dismantled by the very laws that created it. To truly grasp the bigness of the universe, we must accept that the 93 billion light-years we can see is not the whole. It is just the allowed. We are looking through a pinhole in a dark curtain. The wall is the curtain and light is the pinhole. But what is on the other side? If the observable universe is a sphere 46 billion light-years in radius, how much more is out there in the dark? What if our entire 93 billion light-year bubble is just a single atom in a structure that is infinite? What if the Big Bang was not the beginning of the whole universe, but just a local event in an endless ocean of fire? In the next section, we are going to step past the speed of light wall and enter the unobservable abyss. we will explore the inflationary universe and the multiverse paradox. We will discover why some scientists believe the true universe is 10 to the power of 23 times larger than what we can see, a number so vast that our entire observable bubble would fit inside it like a single grain of sand inside the Earth. The ladder of scale is about to leave the realm of observation and enter the realm of pure, mind-bending mathematics. Are you ready to see just how much nothing there really is? We have reached the edge of our vision. For over an hour, we have climbed the ladder of cosmic scale, witnessing the Milky Way shrink from a monstrous city of fire into a single microscopic grain of sand in a stadium of 93 billion light-years. We have mapped the great walls, the vast voids, and the intricate filaments of the cosmic web. We have stood at the edge of the speed of light wall and realized that we are trapped in a bubble of fading history. But as we look out into the darkness beyond the most distant light, we must confront the most humbling realization of all. The observable universe, the 93 billion light-year sphere that we have spent our entire history trying to understand, is likely not the whole. It is just a tiny local neighborhood in a structure that is so much larger that our language does not have words for its proportions. This is the unobservable abyss. It is the part of our home that we are forbidden from seeing, a realm that exists beyond the light, where the universe continues into the infinite dark. In this section, we are going to step off the map and look into the abyss to ask the ultimate question: how much more is there? To understand the unobservable abyss, you must imagine standing on the shore of a vast ocean. When you look out toward the water, you see a line where the sea meets the sky. We call this the horizon. To your eyes, that line looks like the end of the world, but you know intellectually that the ocean does not stop there. The water continues for thousands of miles beyond your sight. The horizon is not a physical wall, it is simply a limit of your perspective caused by the curvature of the Earth. The universe follows a nearly identical logic. The observable limit we discussed in Section 7 is our cosmic horizon. It is the furthest point from which light has had enough time to reach us since the beginning of time. But there is no reason, none in physics or in logic, to believe that the universe simply ends because we can no longer see it. Just as the ocean continues past the beach, space-time likely continues past the 93 billion light-year mark. We are standing on a tiny island of light, looking out at a dark ocean that may have no shore. Why is the universe so much larger than what we can see? The answer lies in the first trillionth of a second after the Big Bang. This was the era of inflation, a period of extremely rapid expansion that makes the current expansion of space look like a crawl. During inflation, the fabric of the universe stretched faster than the speed of light. It took a region of space smaller than an atom and exploded it into a scale of light years in the blink of an eye. This is the what moment that defines our existence. The universe grew so large, so fast, that the light from the other side is still trying to catch up to us. Imagine a balloon being inflated at a speed that defies logic. If you're a tiny ant on the surface of that balloon, your world is only as far as you can see. But the balloon has grown so massive that even if you walked for your entire life at your top speed, you would never reach the other side. You would never even see the edge. We are that ant. The universe inflated with such violence that most of its volume was pushed far beyond our observable bubble before the first photon was ever born. We are living in a universe that outran its own reflection. The unobservable abyss is not just more space. It is the evidence of a birth so explosive that it left us in a permanent state of blindness. How do we know the abyss is there if we can't see it? Scientists use a technique called the flatness test. On Earth, if you walk in a straight line for a few miles, the ground looks flat. But if you measure the angles of a massive triangle across thousands of miles, you will find that the lines curve because the Earth is a sphere. Astronomers have done the same thing with the universe. They have used the Planck satellite to measure the curvature of space-time by looking at the oldest light in existence, the cosmic microwave background. And the result is shocking. As far as we can measure, the universe appears to be perfectly flat, with an error margin of less than 0.4%. This is our next pattern interrupt. If the universe is flat, it means it is either truly infinite, or it is so gargantuan that our observable bubble is just a tiny microscopic patch on its surface. Imagine being an ant on a balloon the size of the sun. To you, every direction looks perfectly flat. You see no curve, no edge, and no end. Based on this measurement, some cosmologists estimate that the true universe is at least 250 times larger than the observable universe. But others believe the number is much higher, 10 to the power of 23 times larger. That is a 1 followed by 23 zeros. If this is true, our entire 93 billion light-year universe is to the whole what a single atom is to the entire Earth. We have spent an hour mapping a grain of sand, believing we were mapping the desert. But as we look into the abyss, the scale stops being about numbers and starts being about self. If the universe is 10 to the power of 23 times larger than what we can see, it is essentially infinite. And in an infinite universe, the laws of probability lead to terrifying conclusions. This is the rule of large numbers. If you have enough space and enough time, every possible arrangement of matter must repeat. Not just once, but an infinite number of times. In the unobservable abyss, there may be another galaxy exactly like the Milky Way. There may be another sun exactly like ours. And there may be another planet Earth, where another version of you is sitting in a room, listening to these exact same words. This is the multiverse paradox of scale. We think of ourselves as unique because we are small and our world is limited. But the bigness of the universe threatens to erase our uniqueness. The abyss is not just empty space. It is a hall of mirrors where every possibility is realized and every history is replayed. The more we realize how big the universe is, the more we realize that we might be a repeating pattern in a machine that has no end. We have reached the limit of what mathematics and observation can tell us about our own universe. We have seen that beyond our horizon lies an abyss that dwarfs our reality by factors we cannot even name. But there is one final rung on the ladder. What if even the unobservable abyss, even the infinite universe we just imagined, is still not the everything? What if our Big Bang was not a unique event, but just one bubble in an eternal ocean of fire? In the next section, we are going to explore the multiverse paradox and eternal inflation. We will discover why some physicists believe that bigness is not a measurement of space, but a measurement of dimensions. We will see why our 93 billion light-year home might be just one page in an infinite book, and why the true scale of the universe might be a number that makes infinity itself look small. The ladder of scale is about to break the boundaries of our dimension. Are you ready to see the everything that exists outside of existence? We have spent the entire history of our species defining the word universe as everything that exists. From the first cave paintings to the most advanced quantum simulations, we have operated under a single comforting assumption that there is only one room. We believed that the Big Bang was the singular birth of reality, a one-time event that created the space, the time, and the matter that we call home. We looked at our 93 billion light-year bubble and called it the everything. But as we reach the 10th rung of our ladder, we are forced to confront a possibility that is so vast, so alien, and so unsettling that it threatens to dismantle the very concept of existence. This is the multiverse paradox. It is the realization that our entire universe, everything we have mapped from the Sun to the Hercules Great Wall, might be nothing more than a single microscopic bubble in an infinite boiling ocean of fire. We are about to discover that bigness is not a measurement of distance, but a measurement of frequency. We are about to see that we are not the protagonists of a cosmic story, but a statistical accident in a machine that never stops. To understand the multiverse, we must return to the era of inflation, the first trillionth of a second after the Big Bang. As we discussed in Section 9, inflation was a period of extremely rapid expansion that pushed the edges of our universe far beyond our sight. We have always assumed that inflation was a temporary phase, that it started, it happened, and then it stopped, allowing the stars and galaxies to form. But modern physics suggests a much darker reality. What if inflation never stopped? This is the theory of eternal inflation. Imagine the fabric of space-time as a massive, infinite sheet of dough that is constantly being stretched in every direction. In most places, the stretching is so violent and so fast that matter can never form. But in tiny, localized pockets, the stretching slows down. The energy of the vacuum decays and a big bang occurs. These pockets become bubble universes, closed systems of light and gravity that are born, expand, and age in isolation. This is the wait. What moment that changes the scale of our journey? We are living inside one of these bubbles. Our Big Bang was not the beginning of the whole. It was just a local weather event in an infinite inflationary sea. Beyond our 93 billion light-year horizon, the dough is still stretching. New Big Bangs are occurring right now, thousands of them every second, creating a tapestry of universes that have no connection to our own. We are not living in the universe. We are living in a multiverse, a fractal, self-repeating structure that has no beginning and no end. On this scale, the ladder we have been climbing doesn't just reach the ceiling. It crashes through it into a building that has an infinite number of floors. But the paradox of the multiverse is not just about quantity, it is about the laws of the room. On Earth, we believe the laws of physics are eternal and universal. We think that gravity, electromagnetism, and the speed of light are the same everywhere. But in a multiverse of infinite bubbles, the laws of physics are just local settings. When a bubble universe is born, the way space-time folds determines its fundamental constants. In one bubble, gravity might be so strong that it crushes stars into black holes before they can ever ignite. In another, the nuclear force might be so weak that atoms can never form, leaving the entire universe as a cold, dark fog of subatomic particles. In yet another, there might be 10 dimensions of space and 0 dimensions of time. This leads us to the anthropic trap. We look at our universe and see a Goldilocks reality, a world that is perfectly tuned for life. The gravity is just right, the light is just right, and the chemistry is just right. We have spent centuries believing that this tuning is a sign of our importance or a miracle of design, but the multiverse tells us a much colder story. In an infinite ocean of bubbles, most universes are dead on arrival. They are chaotic, violent, or empty hellscapes where life is physically impossible. We don't live in a miracle bubble because we were chosen. We live here because this is the only bubble where the laws of physics allowed us to exist. We are the winners of a cosmic lottery that has trillions of losers. We are the survivors of a statistical graveyard, looking at our reflection in the water and calling it a god. Think about the psychological toll of this uniqueness erasure. Throughout this documentary, we have felt smaller and smaller as the scale grew, but the multiverse takes away the last thing we had left, our identity. If the multiverse is truly infinite, and the laws of physics repeat across bubbles, then every possible arrangement of atoms must occur an infinite number of times. This is the level 1 multiverse. Somewhere out there, beyond the reach of our light, there is another bubble that looks exactly like ours. There is another Milky Way, another sun, and another Earth. And on that Earth, there is another version of you, living a life that is identical to yours in every detail. But there are also versions of you who made different choices. There is a version of you who is a king, a version who is a beggar, and a version who died before they were born. In the multiverse, your life is not a unique story. It is a data point in an infinite set of permutations. You lose the rarity of your soul. You are a repeating pattern in a machine that has no memory. This is the ultimate existential dread of scale. The bigness of the universe doesn't just make you small, it makes you redundant. We are like children who thought we were the only ones in the world, only to realize we are part of an infinite assembly line of identical rooms, and we can never, ever leave ours. The speed of light wall we discussed in Section 8 is not just a limit for our telescopes. It is a biological and physical cell that keeps us from ever meeting our other selves. But as we look at these infinite bubbles, we encounter the collision paradox. If there are an infinite number of universes expanding in a single sea of spacetime, do they ever touch? Astronomers are currently looking for bruises in the sky, tiny circular distortions in the cosmic microwave background that might be the evidence of our bubble bumping into another universe shortly after the Big Bang. If we were to find such a bruise, it would be the first physical proof that our reality is not alone. It would be a knock on the door from another infinity. For a moment, the scale would jump again, and we would have to ask, what lies in the space between the bubbles? What is the bulk, the higher dimensional medium that contains the multiverse? This is the point where the ladder of scale leaves the realm of space and enters the realm of dimensions. Some physicists believe that our entire four-dimensional universe is just a membrane, a thin, vibrating slice of a much larger 11-dimensional reality. In this vision, the bigness of the universe is not measured in light years, but in proximity. Another entire universe could be sitting just a fraction of a millimeter away from you, hidden in a fifth dimension you cannot see. We are like flat drawings on a page, unaware that the book we are in has 1,000 other pages stacked on top of us. We are looking for scale in the horizontal, while the universe is expanding in the vertical. The everything we have mapped is just a shadow cast by a higher dimensional light. As we reach the peak of the multiverse paradox, we realize that the question, how much bigger is the universe, has no answer. Because in an infinite fractal multiverse, there is no total, there is no final number. We are standing in a house of mirrors where every mirror is a universe and every reflection is an infinity. We have climbed the ladder from the grain of sand to the stadium, only to realize that the stadium is inside a bubble and the bubble is in a sea and the sea is infinite. We have reached the limits of the human mind. Our language, built for a world of starting and ending, fails us here. We cannot feel the multiverse, we can only calculate it. But there is one final rung on our ladder. After seeing the trillions of galaxies, the great walls, the unobservable abyss, and the infinite bubbles of the multiverse, we must return to the one thing we can truly know, ourselves. We must ask, what does this scale mean for the human spirit? If we are so microscopic, so redundant, and so isolated, then why does our curiosity still burn so bright? Why do we still scan the sky for the neighbor's house, when we know the neighborhood is infinite? In the next section, we are going to look at the mathematics of zero and the final perspective. We will discover why being nothing might be the most powerful thing in the universe, and why the true scale of everything is not a number, but a choice. The ladder is about to end, and as we look down from the height of infinity, we are going to see the Earth for what it really is. Are you ready for the final verdict? We have reached a threshold where language begins to fail. Throughout this journey, we have used words like monstrous, gargantuan, and infinite to describe the rungs of our cosmic ladder. We have talked about hundreds of billions of stars, trillions of galaxies, and light years measured in the tens of billions. We have watched our home, the Milky Way, shrink from a sprawling empire into a microscopic speck in a multiverse that has no end. But as we stand at this peak of scale, we must confront a truth that is far more unsettling than the numbers themselves. The problem is not the size of the universe. The problem is the biology of our minds. We are a species that evolved to count apples, to measure the distance to the next watering hole, and to track the seasons of a single, small planet. Our brains are hardwired for the local. We are functionally incapable of feeling the numbers we have discussed. In this section, we are going to explore the mathematics of zero. We are going to discover why, in a universe of infinite scale, the Milky Way and everything inside it mathematically represents exactly 0% of reality. We are about to see that our sense of importance is not a fact of physics, but a glitch in our perception. To understand the cognition gap, we must first look at the illusion of large numbers. On Earth, we use the word billion as if it is something we can comprehend. We talk about billion-dollar budgets or a billion people on a continent, but the human mind cannot visualize a billion. If you were to sit down right now and start counting to 1 million, one number per second, it would take you about 11 days of non-stop counting. That is a manageable number, a long vacation. But if you wanted to count to 1 billion, it would take you 31 years. Most of us will not have a billion seconds left in our lives. Now think back to section 1. The Milky Way has 400 billion stars. To count the suns in just our own galaxy would take you over 12,000 years. Our history, our civilizations, and our languages would rise and fall multiple times before you even finished counting the neighbors in your own small backyard. This is the weight. What moment of human perception? We are trying to navigate a universe of trillions using a brain that is overwhelmed by a single billion. When we say there are 2 trillion galaxies in the observable universe, we are using a number that is 62,000 years of counting. We are shouting into a canyon so deep that the echo will never return. This is why we rely on analogies: the grain of sand, the dinner plate, the football stadium. These are not just teaching tools, they are cognitive crutches. They are the only way we can keep our sanity while looking into an abyss that has no floor. We use the small to mask the terror of the large, never realizing that the analogies themselves are failing to capture even a fraction of the truth. But the real horror begins when we move from big numbers to infinity. As we explored in the multiverse paradox, if the universe is infinite, we encounter a mathematical law that erases our existence. In mathematics, if you take any finite number, no matter how large, and divide it by infinity, the result is always 0. Think about what that means for our story. The Milky Way contains 400 billion stars. That is a massive, staggering number. But 400 billion divided by infinity is 0. The 2 trillion galaxies of the observable universe, a structure 93 billion light-years wide, divided by infinity is 0. Mathematically, our entire observable universe, with all its history, its light, and its life, represents 0% of the multiverse. We are not small, we are not minor. We are, in the eyes of absolute scale, non-existent. We are a rounding error in a calculation that doesn't need us. This leads to the uniqueness paradox. On Earth, we feel unique because we are rare. We are the only planet we know with life. We are the only species we know with consciousness. This rarity is the foundation of our ego and our religions. But in an infinite multiverse, rarity is impossible. If the room is infinite, then every possible event must happen an infinite number of times. This is the infinite monkey theorem applied to the cosmos. If you have an infinite number of monkeys hitting keys on an infinite number of typewriters, they will eventually produce the complete works of Shakespeare. Not by skill, but by the sheer cold pressure of probability. In an infinite universe, you are not a miracle. You are a mathematical inevitability. There are an infinite number of Milky Ways, an infinite number of Earths, and an infinite number of versions of you listening to these words right now. The bigness of the universe doesn't just make you a 0, it turns you into a repeat. It strips away the one thing we thought we had, our one-of-a-kind story. Think about the psychological toll of statistical insignificance. Throughout this journey, we have felt the ladder of scale grow more and more alien, but the mathematics of 0 is the final blow to the human spirit. It tells us that our everything is a local anomaly. We are like a single flickering pixel on a screen that is billions of miles wide. If that pixel goes out, the screen doesn't notice. If our galaxy were to vanish tomorrow, if every star in the Milky Way were to be snuffed out like a candle, the universe would not change. The filaments of the cosmic web would not ripple. The great attractor would not lose its grip. The expansion of space would not slow down. We are living in a universe that is profoundly indifferent to our existence. The silence of the stars we discussed in earlier sections is not a mystery to be solved. It is the natural sound of a system that is too large to hear us. But here is the pattern interrupt that saves us from total despair. Even if we are mathematically zero, we are a zero that observes. This is the anthropic pivot. We have spent 2 hours mapping a universe that is designed to erase us. We have used our 3-pound brains to calculate the mass of black holes and the radius of the inflationary sea. We have looked at the speed of light wall and understood it as a cage. There is a strange, defiant power in being a microscopic observer. The universe is vast, but it is also blind. A star is a billion times larger than you, but it does not know it is a star. A galaxy contains 400 billion suns, but it has no map of itself. We are the eyes of the universe. We are the only part of the cosmic machine that has woken up and asked, "How big am I?" The mathematics of zero tells us we are nothing, but the science of observation tells us we are the meaning. Without an observer, the universe is just a collection of cold matter and expanding space. It is a play performed in an empty theater. By climbing this ladder of scale, by feeling the vertigo of the unobservable abyss and the multiverse paradox, we are performing the ultimate act of cosmic rebellion. We are refusing to be zero. We are turning our insignificance into a question, and that question is the only thing that actually fills the void. We are a bridge made of logic and wonder, stretching across a gap that physics says we shouldn't be able to cross. But as we reach the end of our mathematical exploration, we must face the information limit. We have calculated the size, the volume, and the probability of the universe. We have used math to peer into the dark where light cannot go. But math has its own walls. There are Gödel's incompleteness theorems and the limits of computation. There are parts of the universe that are not just unobservable, but unknowable. We are approaching the end of the ladder, where the numbers stop being tools and start being mysteries. We have seen how much bigger the universe is than our galaxy, but we are about to realize that the bigness is not the point. The point is the perspective. What happens to the human mind when it finally accepts that it is a zero in an infinite sea? Does it collapse into nihilism, or does it expand into a new kind of freedom? In the final section of our journey, we are going to step away from the numbers, the galaxies, and the superclusters. We are going to return to the Earth, the grain of sand, and we are going to look at the night sky one last time. We are going to discover the final perspective. We will see why the true scale of the universe is not measured in light years, but in the audacity of a species that dares to look up. The ladder of scale is about to end, and as we look down from the height of infinity, we are going to find the only thing that actually matters in a trillion light-year abyss. We are going to find home again, but this time, it will look nothing like the home we left. We have reached the end of the ladder. For over 2 hours, we have climbed through the layers of the cosmos, witnessing our reality expand until the numbers themselves became a form of noise. We have watched our home, the Milky Way, shrink from a sprawling empire of 400 billion stars into a microscopic speck, a single flickering pixel in an observable bubble 93 billion light-years wide. We have looked into the unobservable abyss and the infinite bubbles of the multiverse, realizing that everything we have ever known mathematically represents exactly 0% of what truly exists. We have stood at the edge of the speed of light wall and felt the isolation of a species trapped on a sinking island of history. And now, at the summit of this exploration, we are left with a silence that is deeper than the void between galaxies. We are faced with the ultimate question: what does it mean to be microscopic? What does it mean to be a zero in an infinite sea? In this final section, we are going to return to where we started, to the grain of sand, to the pale blue light, and to the human heart. We are going to discover the final perspective, the realization that the true scale of the universe is not measured in distance, but in the audacity of a mind that dares to look back at the dark. To find the meaning of scale, we must first descend the ladder we have spent so long climbing. Imagine zooming back through the filaments of the cosmic web, watching the great walls and the superclusters dissolve into distant light. We pass through the Laniakea watershed, following the rivers of gravity toward our local neighborhood. We see the Andromeda galaxy, our rival and future self, growing larger in the window. We re-enter the Milky Way, diving through the thick disk of ancient stars and into the vibrant, blue-lit suburbs of the Orion Arm. We find our sun, that medium-sized, unremarkable yellow dwarf, and we look for its third planet. We zoom in past the Oort cloud, past the gas giants, until we find a tiny, fragile sphere wrapped in a thin layer of nitrogen and oxygen. We return to the Earth. After witnessing the bigness of the universe, the Earth looks different. It no longer feels like a solid, eternal foundation. It feels like a miracle of extreme improbability. On Earth, we argue about borders, we fight over ideologies, and we obsess over our local dramas. But from the perspective of the 93 billion light-year bubble, those dramas vanish. We are a collection of conscious atoms living on a wet rock that is currently screaming through a vacuum that is actively trying to erase us. This is the first layer of the final perspective, the realization that rarity is the only true currency of the universe. The universe is massive, but most of it is empty. Most of it is cold. Most of it is dead. The bigness we have explored is a vast desert of radiation and dark energy. The smallness of the Earth is the only place we know where the universe has woken up. This leads us to the miracle of the zero. We have seen that mathematically, our existence is a rounding error. But in the world of biology, a zero that thinks is more powerful than an infinity that is blind. A star is a billion times larger than you, but it does not know the laws of nuclear fusion that keep it alive. A galaxy spans 100,000 light-years, but it cannot calculate its own mass. The Hercules Great Wall is the largest structure in existence, but it has no memory of its own birth. You, however, do. You have used a 3-pound organ, made of the same stardust that built the galaxies, to map the entire history of time. You have decoded the light of stars that died before the Earth was born. You have understood the curvature of space-time and the expansion of the void. The universe is the stage, but you are the audience. And a play without an audience is just a series of random movements in the dark. This is the second layer of the final perspective, the ancestry of atoms. We often feel disconnected from the scale of the universe because we feel separate from it. We think of the universe as a container and ourselves as the contents, but the science of scale tells us a different story. Every iron atom in your blood was forged in the core of a massive star that exploded billions of years ago. Every carbon atom in your DNA was created in a previous generation of the galaxy. The calcium in your teeth, the oxygen in your lungs, and the silicon in your technology are all recycled remnants of the Big Bang. You are not in the universe. You are a part of the universe that is looking back at itself. When you look at the Milky Way through a telescope, you are the universe using its own atoms to observe its own structure. We are the sensory nervous system of the cosmos. The bigness of the universe is not a threat to our importance. It is the measure of our heritage. We are the way the universe knows it exists. But as we embrace our cosmic heritage, we must also face the responsibility of the speck. Throughout this journey, we have seen how fragile our observable window is. We have seen that the expansion of space is carrying the galaxies away from us, and that one day the sky will be empty. We live in a brief, golden hour of cosmic history. We are the only generation of life that will ever be able to see the 2 trillion galaxies. Our ancestors were too primitive to see them, and our descendants will be too isolated to find them. This creates a terrifying sense of urgency. If we are the only eyes in the dark, then every discovery we make, every song we write, and every life we protect is a victory for the entire multiverse. We are the guardians of meaning in a trillion light-year abyss. If we fail, the universe doesn't just lose a species, it loses its own ability to be understood. This is the moment where the mathematics of zero turns into the logic of freedom. If we are mathematically insignificant, then we are free from the pressure of cosmic destiny. We don't have to be the center of the universe to have a life that matters. We don't have to be the protagonists of an infinite story to write our own chapters. The bigness of the universe gives us a blank canvas. It tells us that the universe is indifferent, which means we are the ones who get to decide what is important. We get to choose that a single human connection, a single act of kindness, or a single moment of wonder is more valuable than a billion sterile suns. The scale of the universe is a reminder that importance is a human invention, and it is the most beautiful thing we have ever created. Think about the audacity of curiosity. Why have you watched this for 2 hours? Why do we build billion-dollar telescopes to look at light that will never reach us? Why do we care about the great attractor or the unobservable abyss? It is because there is something inside the human spirit that refuses to be limited by its biology. We are infants in a backyard, yes, but we are infants who have learned to use the shadows on the wall to map the entire house. Our curiosity is a rebellion against our scale. It is a bridge made of logic and imagination that allows a microscopic species to touch the face of infinity. The fact that we even want to know how big the universe is the final proof that we are larger than our bodies. As we conclude this journey, I want you to look at the night sky one last time. But this time, don't look at it as a map of distance. Look at it as a map of connection. Every point of light you see is a sun that follows the same laws as yours. Every smudge of dust is a galaxy that grew from the same primordial ripples. Every void is a room in the same house. The bigness of the universe is not a wall that keeps us out. It is the ocean that connects us all. We have seen that the universe is unimaginably larger than our galaxy, but we have also seen that the human mind is large enough to contain the universe. The final verdict of our exploration is this: we are nothing and we are everything. We are a rounding error in the math of the multiverse, but we are the heartbeat of the observable world. We are trapped behind the speed of light wall, but our thoughts have already crossed it. We are a grain of sand in a stadium, but we are the only ones who know the score. The scale of the universe is not meant to make you feel small, it is meant to make you feel expanded. It is a reminder that your reality is not confined to your street, your city, or even your planet. You are a passenger on a galactic ship, part of a supercluster flow, and a citizen of a 93 billion light-year miracle. As the sun sets and the first stars begin to appear, remember that you are looking at the tip of an iceberg that has no end. The Milky Way is your home, but the universe is your horizon. And while the distances may be vast and the silence may be deep, you are not alone in the dark. You are part of the light. You are the universe waking up. You are the final perspective. Thank you for joining me on this 2-hour journey through the scales of existence. If this exploration has changed the way you feel about your place in the cosmos, please take a moment to like the video and subscribe to the channel. Your support allows us to continue building these bridges into the unknown. And the next time you feel overwhelmed by the world, just remember, you are a zero that observes infinity. And in a universe of infinite scale, that is the greatest triumph of all. Good night and keep looking up. The universe is waiting for you to see it.